In continuation of the previous isometric projections in engineering drawing, in this online engineering drawing lesson, isometric projections are as previously in continuation above the previous class is the previous class of the isometric projections. Problem number 2b. Draw the isometric projection of hollow cylinder, hollow rectangular prism of base 55 into 45 mm, outside dimensions, height 75 mm and thickness of 8 mm when its axis is horizontal. Now let us analyze this one. This is the top view. This is the front view. And the perpendicular positions of each parallel and perpendicular positions of each intersection you may get. This is the top view and front view highlighted, and with the isometric view of the prism got. So like that, once again, this is the isometric view. Now with this concept, let us try to draw on drawing sheet. Draw the orthographic view of hollow rectangular prism. The front view of the prism is shown at the bottom for convenience. Draw the horizontal line nearby and mark a point B on it. Draw the two inclined isometric axes at B. The axes are inclined at 30 degrees to horizontal line and at 120 degrees to each other. Mark a point 55 mm from B. On the left hand side is isometric line and name it as A. Similarly, mark a point 75 mm on the right hand side isometric line and name it as B1. Draw isometric lines from B1 and respectively parallel to AB and BB1 to meet at A1. Draw vertical lines from AB, A1 and B1 and mark a point on each of them at 45 mm from the respective lower point. Name the upper points respectively as D, C, D1 and C1. Join CD, C1D1, CC1 and DD1. Now mark points on BC, 8 mm from B and C and name them as X1 and X respectively. Draw two isometric lines from X and X1 parallel to AB to meet AD at X2 and X3 respectively. Mark points on x-x to 8 mm from x-x to x and x2 and draw vertical lines from these points parallel to BC to meet x1, x3. Similarly, draw the corresponding isometric lines at the rear side and rectangular prism. Draw visual entities, that is, visible edges of prism in isometric view. Once again, draw orthographic view of the halo rectangular prism. The front view of prism is shown at the bottom of for convenience. Draw horizontal line nearby and mark a point B on it. Draw the two inclined isometric axes at B. The axes are inclined at 30 degrees to horizontal line and 120 degrees to each other. Mark a point 55 mm from B on left hand side isometric line and name it as A. Similarly, mark a point 75 mm on right hand side isometric line and name it as B1. Draw isometric lines from B1 and respectively parallel to AB and BB1 to meet at A1. Draw vertical lines from AB, A1 and B1 and mark a point on each of them at 45 mm from the respective lower point. Name the upper points respectively as DC, D1 and C1. Join CD, C1, D1, CC1 and DD1. Now mark the points on BC, 8 mm from B and C and name them as X1 and X respectively. Draw two isometric lines from X1 parallel to AB to meet at X2 and X3 respectively. Mark points on XX2, 8 mm from X and X2 and draw vertical lines from these points parallel to BC and to meet X1, X3. Similarly, draw corresponding isometric lines at the rear side of the rectangular prism. Darken the visual entities, that is the visible edges of the prism in the isometric view. Now next 2C, problem number 2C. Draw three possible ways of representing the isometric projection of hexagonal prism with side of base 30 mm and height 70 mm. Once again, draw three possible ways of representing the isometric projection of hexagonal prism with side of 30 mm and height 70 mm. Now with this, how the physical view will be available, observe. top view will get like this and front view. So with these two views intersecting, we'll get the isometric view of the prism. Top view will be appeared like that and front view will be available like this. So this is the view of the isometric view of the object. Once again, now with this information concept, you have to try to draw on drawing sheet. Now let us draw the complete orthographic view of hexagonal prism. Enclose the top view in box PQRS as shown in the figure. Draw a horizontal line nearby and mark a point P1 on it. Draw two inclined isometric axes at P1. The axes are inclined at 30 degrees to horizontal line and at 120 degrees to each other. With P1 as center and radii equal to PS and PQ, draw arcs on the isometric lines at S1 and Q1 respectively, so that PS is equal to P1S1 and PQ is equal to P1Q1. Continue. Now draw lines from S1 and Q1 respectively parallel to P1Q1 and P1S1 to meet at R1. Draw vertical lines from P1, S1, R1 and Q1. Mark a length 70 mm on each of these lines and name the corresponding top ends respectively as P, Q, R and S. Now join PS and PQ, QR and SR. Mark lengths equal to Y from P1 and Q1 on P1 Q1 and name the points as B1 and C1. Mark length equal to X from P1 or S1 on P1 S1 and name the point as A1. That is, A1 is midpoint of P1 S1. Draw lines from B1 and C1 parallel to P1 S1 to meet S1 R1 respectively at F1 and E1. Draw a line from A1 parallel to P1 Q1 to meet Q1 R1 at D1. Join A1 B1, B1 C1, D1 E1, E1 F1 and F1 A1. Draw vertical lines from A1 B1, C1 D1, E1 and F1 and indicate to corresponding corners of the top face of the prism as A, B, C, D, E and F respectively. Join AB, BC, CD, DE, EF and FA to get the isometric view of hexagonal prism. Darken the visual entities, that is visible edges of prism in the isometric view. Once again, draw complete orthographic view of hexagonal prism. Enclose the top view in box PQRS as shown in figure. Draw a horizontal line nearby and mark a point P1 on it. Draw the two inclined isometric axes at P1. The axes are inclined at 30 degrees to horizontal line and at 120 degrees to each other. With P1 as center and radii equal to PS and PQ, draw arcs on the isometric lines at S1 and Q1 respectively, so that PS is equal to PS P1 S1 and PQ is equal to P1 Q1. Draw lines from S1 and Q1 respectively, parallel lines to P1 Q1 and P1 S1 to meet at R1. Draw vertical lines from P1, S1, R1 and Q1. Mark length 70 mm on each of these lines and name the corresponding top ends respectively as P, Q, R and S. Join PS, PQ, QR and SR. Mark lengths equal to Y from P1 and Q1 on P1, Q1 and name the points as B1 and C1. Mark lengths equal to X from P1 or S1 on P1, S1 and name the point on A1. A1 is the midpoint of P1, S1. Draw lines from B1 and C1 parallel to P1 S1 to meet S1 R1 respectively at F1 and E1. Draw a line from A1 parallel to P1 Q1 to meet Q1 R1 at D1. Join A1 B1, C1 B1 C1, C1 D1, D1 E1, C1 F1 and F1 A1. Draw vertical lines from A1, B1, C1, D1, E1 and F to F1 and indicate corresponding corners of the top face of prism as A, B, C, D, E and F respectively. Join AB, BC, CD, EE, EF and FA to get the isometric view of the hexagonal prism. Now darken the visual entities, that is visual edges of the prism in isometric view. Now problem number 3. Draw isometric view of hexagonal pyramid of base 25 mm and height 60 mm when it is resting on HP such that an edge of base is parallel to VP. Now let us view enlarged fashion. This is the front view and top view available, and with this simple concept you may analyze a physical appearing view like this in isometric representation, isometric view, that is top view and front view which is available in front view, and top is like that. So with this, once again you see, now with this concept you try to draw on drawing sheet. Now let's draw the orthographic view of hexagonal pyramid enclosed top view in box PQRS as shown in figure, that is front view and top view. Now let's draw the horizontal line nearby and mark point P on it. Now draw two inclined isometric axes at P as previously, that is 30 degrees, 30 degrees towards X and towards X dash, like that from P. With PI center and radius equal to PQ, draw arc on both isometric lines to cut them at Q and S. Now draw lines from S and Q parallel to PQ and SPS respectively to intersect at R. Now mark the point A and B on PQ, the isometric view, and such that PA and PB is equal to small pa and small pb. The marked distance equal to PF obtained in top view on line PS in the isometric view. Draw lines from A and B parallel to PS to meet the line SR at E and D. Now draw a line from F parallel to PQ to meet PQR at C. Now join AB, BC, CD, DE and FA. Locate a point AO as the midpoint of FC, height of 60 mm in isometric view. Join OE dash and OB dash, CO dash, DO dash, EO dash and FO dash to get the isometric view of the hexagonal pyramid. Now darken the visible edges of pyramid. Once again, draw the work paper views of hexagonal pyramid enclosed top view in box PQRS. Draw the horizontal line nearby and mark point P on it. Draw two inclined isometric axes at P with P as the center and radius equal to PQ. Draw arcs on both the isometric lines to cut them at Q and R. Draw lines from S and Q parallel to PQ and PS respectively to intersect at R. Mark point A and B on PQ in the isometric view such that PA and PB is equal to small pa and small pb. Now mark distance equal to PF obtained in the top view on line PS in isometric view. Draw lines from A and B parallel to PS to meet the line SR at E and D. Draw a line from F parallel to PQ to meet QR at C. Join AB, BC, CD, DE, EF and FA. Now locate the point O as the midpoint of FC, that is height of 60 mm in the isometric view. Join AO dash, BO dash, CO dash, DO dash, EO dash and FO dash to get the isometric view of the hexagonal pyramid. Now darken the visible edges of the pyramid. Now problem number 4. Once again, now let us see physical view. Now once again analyze. Now with this concept, try to draw on a drawing sheet. Repeat. Now cylinder and cone. Isometric view of cylinder and cone. Problem number 8. Draw the isometric view of cylinder of a 40 mm dia and 60 mm height when it rests with one of its ends on the HP. Once again, draw the isometric view of cylinder 40 mm and diameter 60 mm, height when it rests with one of its ends on the HP. Let us observe. This cylinder is like this. So with this, let us analyze physically what is happening in this problem. Once again, now problem number 5a. Problem number 5. Try to draw on a drawing sheet. Let us analyze. Draw the orthographic view of cylinder. Enclose the top view in a square EQRS. As shown in figure, that is the top view and the front view. Now you remember that what are the physical shape of this view will be appeared or changed as it is shown previous one. So with that concept, now you are drawing on the drawing sheet. Now mark A, B, C and D as points at which the square touches the circle. Now join the points TR, AR, CP, BP and SQ to locate the intersection points. Now draw isometric axis from point P as previous one, that is 30 degrees to x dash and 30 degrees to x. X if the axis is x dash as previous explanation. With P as center and radius equal to PQ taken from the top view. Draw arcs on the 30 degrees lines to cut them at S and Q. Draw lines from S and Q parallel to PQ and PS respectively. Name the point of intersection as R. Construct an ellipse by using four center method, which is isometric view of base given cylinder. Now construct isometric box of height 60 mm. Construct corresponding ellipse on top of the box and draw extreme generators of the cylinder. Darken visible entities to get the isometric view of given cylinder. Which is the required isometric view. Now once again, draw orthographic views of cylinder. Enclose the top view as a view in a square PQRS. Mark A, B, C and D as the points at which square touches the circle. Join the points DR, AR, CP, BP and SQ to locate the intersection points. Now draw the isometric axis from point P. As previous explanations given, like 30 degrees if axis is xx dash, towards x dash is 30 degrees and towards x is 30 degrees. That is the isometric angle from the point P. Now with P as center and radius equal to PQ taken from the top view, draw arcs on 30 degrees lines to cut them at S and Q. Now draw lines from S and Q parallel to PQ and ES respectively. Name the point of intersection as R. Now construct an ellipse by using four center method, which is isometric view of the base of the given cylinder. This is the four center method, that is four centers from four centers to draw the opposite corners. Draw lines to opposite corners. This we can call it as a four center method. These lines to be intersected at O1, O2. So from that O1 as center and O2 as center, you can draw an arcs in different points, centers. You may get the isometric view of the given object. Now construct the isometric box of height 60 mm. Now with this construct a corresponding ellipse on the top of box and draw extreme generators of the cylinder. Now darken the visible entities to get the isometric view of given cylinder. In this way, you may draw isometric view of a cylinder. Now with this information or with this discussion today, we will close the online lesson of the isometric projections of the subtopic in cylinder and cones with the problem number 5. So let us close, and the next class will be continued with the problem number 6. Thank you.